Now let us see the mechanism of acid catalyzed hydration. Okay. See, in the first step, the lone pair abstracts a proton. I mean, it acts as a base, the oxygen atom, and abstracts the proton. Then we get a protonated ether. Okay, so this is a protonated ether or protonated epoxide, we can say. Of course, water molecule is eliminated, right? Now, this protonated epoxide is further attacked by water molecule. Okay. Now, look at the two carbon atoms to which oxygen is attached. This is more hindered or more crowded, whereas this one is less hindered or less crowded. Okay. So now this lone pair on oxygen attacks the more hindered carbon in an anti manner. More hindered carbon is attacked in anti manner because the more hindered carbon is the one that is forming a more stable carbocation. Okay. Now, because of this anti attack, we get okay. This is what we get. And finally, using a water molecule, you can just take out a H plus to finally get a 1,2-diol with anti kind of arrangement. Okay, so this is all about the acid catalyzed ring opening of epoxides. The most important one is more hindered carbon is being attacked. Okay, now let us go for the base catalyzed ring opening of epoxide. Okay, see in this case, the less hindered carbon is attacked. Okay, let us see that. This is more hindered, and of course, this is less hindered. Okay, let us consider methoxide and methyl alcohol. Okay, we'll be getting CH3, CH, OH, CH2, OCH3. Okay, if suppose OH minus is considered, we get a diol again, but because we have considered methoxide, we are getting this. Let us see the mechanism. Coming to the mechanism, see this methoxide ion attacks the less hindered carbon in an SN2 manner. Okay, now here we get CH3, CH, this will be O minus, this of course is CH2, OCH. Then taking the methyl alcohol, you can abstract a proton to get methoxide again. Okay, See here the attack is SN2, so therefore the one that is less hindered is attack. So very important. In the previous case, the attack was on more hindered carbon because it proceeded via a more stable carbocation. In this case, it is on the less hindered carbon because here the attack is by SN2 mechanism. Okay. Next, here of course it is methoxide. Okay. Next. Now with Grignard reagent, even in this case also the less hindered carbon is attacked. Look at this. When treated with the Grignard reagent, okay, it is this. Now the attack is on this less hindered carbon or less crowded carbon. Okay, immediately this goes here, and of course it gets a negative charge. We'll see that CH3, CHO, O minus, then Mg plus X, CH2R. Okay. Now when a water molecule is added, or let me say on hydrolysis in the presence of acid, it can be written as H plus and OH minus. Now this minus with H plus, then this one goes off. So we get CH3, CH, O minus and H plus, then CH2R. Along with this, we get magnesium hydroxy halide. Okay. This is how with the Grignard reagents also we get alcohols. Okay. Next. Now from carbonyl compounds. First one is using the lithium aluminum hydride in ether. A very good reducing agent. In fact, the strong reducing agent. Let us see how lithium aluminum hydride is prepared first. You know, lithium hydride on reaction with anhydrous aluminum chloride forms lithium aluminum hydride. For that we need to take 4 moles of course, we'll be getting lithium chloride, 3 moles of that. Now in this, it will be like this, Li plus AlH4 minus. Now let us see the mechanism with lithium aluminum hydride taking a carbonyl compound. Okay. Now let us consider this lithium aluminum hydride in a convenient manner. Okay. In this case, because oxygen is more electronegative, it gets a negative charge. Carbon gets a positive charge. Now it's negative to positive, negative to positive. Okay. This negative has to be from H minus, because the negative itself is because of this. Okay. So that the negative charge will go off. Now this hydrogen is moving away in the form of hydride. I mean with the bonded pair of electrons. Okay. Now R, C, then R dash. So this O minus with the AlH3 and then Li plus. And see, you got hydrogen. Now this hydrogen is from lithium aluminum hydride. This is very important because sometimes a different isotope is considered. Now when the same reaction is carried out for 3 more times, okay, because you still have 3 hydrogens here, it can be carried out 3 more times to get this particular compound. Look at this. R, C, R dash, and this O force this H. But this kind of species, you get 3 more. So a total of 4 will be there now, including the one that we got in the beginning. Okay. Then of course we will have aluminium and Li. So because aluminium is connected to 4 species, it has got a negative charge still. Okay. Then now when this is subjected to hydrolysis, we get R, C, R dash, then this H, again this H. But remember, this hydrogen is from the solvent. Okay. It is from the solvent, water, what we have taken. So you get 2 hydrogens. The first one is from lithium aluminum hydride, the one that gets connected to carbon. And now the second one is from the solvent, and this one gets connected to oxygen. Okay. This is a mechanism with lithium aluminum hydride, which of course is a very good reagent. Let us see what all it reduces. uses of lithium aluminum hydride. See, it actually reduces the substances into alcohols and also into amines. Let us first see the compounds which are reduced into alcohols by lithium aluminum hydride. These are all very important. See, aldehydes with lithium aluminum hydride are converted into alcohol. As seen in the mechanism, a hydrogen is attached to this and another to this. So that is how you got this extra H and finally the alcohol. Next, coming to the ketones, on reduction with lithium aluminum hydride, we get this kind of alcohol. Okay. Now, even the carboxylic acids are reduced. You know, carboxylic acids are reduced straight away into alcohol because lithium aluminum hydride is a strong reducing agent. So normally acids are reduced into aldehydes or say carbonyl compounds and then into alcohol. But look at this. With lithium aluminum hydride, acids are converted straight away into alcohol. That is very important. Even the derivatives of carboxylic acid, say acid halide. Acid halide is also reduced into alcohol. Even esters are reduced into alcohol. Two different types of alcohol. Okay. Even the anhydrides. If suppose we take different, we get different alcohols. Otherwise, we can just get similar kind of alcohol. Okay. Next. Even the epoxides are converted into alcohol. Just now we have seen. Okay. Then now the second variety, wherein lithium aluminum hydride reduces the substances into amines. Look at this. Take cyanide. Cyanides on reduction with lithium aluminum hydride forms amines. Okay. Then even nitro compounds are reduced into amines. We can also take azides. Azides are also reduced into amines. cyanides. Of course, cyanides are reduced into primary amines. Let us take isocyanides now. These are reduced into secondary amines. Okay. Next, take isocyanates. Even the isocyanates are reduced into secondary amines. A primary amine, a primary amine. Here also it's a primary amine. In this case, it's a secondary amine. Okay. Now, coming to the applications, lithium aluminum hydride cannot reduce double and triple bonds. Okay. But I mean, under normal conditions, it cannot reduce. Let me give you this example. Okay. In this case, the product that you get is this. The aldehyde has got reduced into alcohol, but see, the double bond is left as such. It is not been reduced, whereas this one got reduced. I mean, the aldehyde is reduced into alcohol, but the double bond remained as such. But there is an exceptional case, a very important exception. That is, in case of cinnamyl systems, even double bonds get reduced. Okay. The double bonds also get reduced with cinnamyl systems. What do you mean by a cinnamyl system? Look at this. It's simply alpha beta unsaturated system. Okay. So this is cinnamaldehyde. Look at this. This is alpha, this is beta. So alpha beta unsaturated aldehyde is cinnamaldehyde. You can also take alpha beta unsaturated acid called cinnamic acid. In such a case, see, even the double bond gets reduced. See, when the double bond gets reduced, you'll get this. And of course, the aldehyde also is reduced. Look at this. Yes, it actually got reduced. Even this, it also got reduced. Okay. Now the reduction with sodium borohydride. Sodium borohydride is a milder reducing agent than lithium aluminium hydride. It is prepared by treating sodium hydride with trimethoxyborane. Look at this. Trimethoxyborane. Get sodium borohydride can be represented as this. Then sodium methoxide. Now let us take the mechanism. Taking carbonyl compound, just as seen in case of lithium aluminium hydride, let me take the same way. Now, a negative charge, a positive charge, minus to plus, and this goes and attacks the positive charge. Again, a hydride is what is attacking the carbon. R, C, R dash, O minus, then O minus with the BH3 Na plus. Okay, now this hydrogen. This hydrogen is from sodium borohydride.